Oh, I love it. There's too much wind noise. Look at this, please. Your own version, I mean. And you'll see that in this part down here, there's the Carboniferous. Above it is the Permian, and then the Triassic. Well, the rocks that I'm looking at behind us, they are the Triassic. And the Permian is missing in this area. But you see very shortly that we go straight from the Triassic to the Carboniferous. And we get a very good uniformity that we go and look at. But before that, we look at the Trias and have a little thought about it. And so you've all got your hard hats on. Can you put them on, please, so that nobody has any rocks on their head, including Rod, just in case you take any photographs. I wouldn't want to talk to you without that. We'll go a bit closer to right, if you come and look at the rocks then. And you can see there's red and there's a sort of almost greenish, they described as green anyway. There's a greenish tint. Now I have mentioned this to you before. Would anyone like to suggest why some of them are red?
Is it iron? No.
It is iron, yes. But what has it got to do with the way they are formed? I mean, you're right about the iron. That's right. The red ones, the rock would have certainly been generated, shall we say, in desert conditions. And so the iron in the rock would have become very oxidized, and that's why it's gone red. It's rust, if you like, as we feel it. Now the greener, well, it is a slightly green tinge, that would have been in a less oxygen rich area as it was laid down. There was less oxygen present, and so it is oxidized, but not as much. And if there's less oxygen integrated with the iron, then you don't get the red colour. You get greys and yellows and greens, depending on exactly what mineral you've got. But they'd all have been laid down underwater, including the red stuff. It would have been the actual material, well, it's mainly clay, would have been oxidized on land and then blown into water, or possibly washed into water when there was heavy rainfall, because even in deserts you get rained out again. So that it would all have been laid out underwater, but in rather dry, I mean obviously it's underwater, so it's not that dry, but it would be in a very hot climate, and there's a good reason for saying that, apart from the fact of the iron oxide, and that is those holes you can see in the cliff there. Those were mainly circular ones, and they are the remains of gypsum, and we'll see some gypsum further on. I mean, there it's been washed out, or dissolved rather. Gypsum is, I've forgotten the exact chemical, so I won't try and quote it, the chemical formula I mean, but gypsum is a salt that gets deposited when lakes and seas dry out, because what happens is the material, the salt that forms gypsum, is dissolved in the sea, and then as the sea dries out in very hot conditions, then it may not get totally dried out, but it is the water is evaporating in the heat, and at the bottom of the sea, as it evaporates, obviously there's less water, and so if it's saturated with gypsum, then the gypsum is going to be deposited, because it can't all be dissolved if the water's evaporating. There isn't enough water to keep it dissolved, and that's what happens. And so in these rocks you will get, it would have been the bottom of the sea then, you'll get quite a lot of gypsum deposited, and that was because it was in a very hot climate, and the sea was, I don't mean it had all gone, but it was evaporating and the gypsum was deposited. And in this part of Britain there's quite a lot of gypsum, but it's not enough to mine. But in parts of Britain, and particularly in Yorkshire, the same age rocks, and there are very thick deposits of gypsum there, and they're mined, and that's what you make plaster with. Plaster for plasterboards, or plaster of Paris that you have on your broken wrist. That's the same material. That is gypsum, basically. They add something to it to make it more workable, but that's what they make it from, is gypsum. And gypsum is very soluble, and the place I know best that has a problem is Ripon. It's a town in, well, a city to be precise, because it's got a very large cathedral in Yorkshire, North Yorkshire, and I went there on a trip one time, and as you're walking about you can see the houses are all sort of funny shapes, and it's because underneath Ripon there are large deposits of gypsum, and they have dissolved. There are caves underneath, and it's because the gypsum is dissolved and the town is settling, basically. It looks very like, you don't see it now, so it perhaps doesn't help you much, but when I was a child, mining was common throughout the mining valleys. Pontypridd, that's where I was brought up, and you often saw houses there, not falling down because they would be supported, but with big wooden props on them to stop them falling over as the mining went on underneath. Well, that's what it's like in Ripon, but there it's natural. So anyway, there we are. The material here, they call it, well, I told you it's the Trias. They use the term marl, M-A-R-L. Now that isn't a strictly geological term, to be honest, but it's very commonly used nevertheless, so it's worth knowing it. And it means that it's a mudstone, really, mainly clay, but there's a fair bit of calcium carbonate in it, lime, that makes limestone. M-A-R-L, the red marl or Triassic marl, that's what these are. And the green marl too, if it comes to that. They'd all be called marls. And so they're rich in calcium carbonate, which makes calcite as well as gypsum. I mean, that's in them too. And that's there because, again, it was where they were laid down. It was, the calcium bicarbonate would have been dissolved in the sea and then got deposited, mixed in with the clays as the sea was evaporating. Right, now we can also find a few faults along here and lovely jointing. Look at this, oh, beautiful jointing here. But I won't try and measure that, that's too steep. That's vertical basically. You wouldn't get much out of that. We'll go and measure, though I can see a flat horizontal, almost horizontal bed over there. We'll go and measure it. Come on. then hopefully we'll find some precipitation. There's one bit there. But we'll find some near the beach. Right. Now I'm hoping, let's see if it's still windy. No, not so bad. I'm intending that you all have a go at measuring dips, but we won't all have a go just here. We'll go out to the headland, and as we're coming back then we'll stop and everyone will have a go at it. But just for now, I'll just pick on some keen volunteer and they can have a go. And we'll measure this dip here. I've got clinometers so that you can share one between two. But I won't hand them out yet. Partly because they're rather expensive. I don't want you to lose them. Here we are. Oh, we also need I brought a special piece of card. Could you hold that, please? And then I get a pencil rather. Yeah. Right. Turn that off for now. Okay. If you lay that on the surface there. And we'll try and measure the dip. So, there's a puddle. Never mind, you won't teach you. So, well, when it's as flat as this, it's a bit difficult to see which way it's dipping, really, to tell the truth. It's a bit of a guess, but which way do you think it's dipping? Towards you or that way? Let's stand back a bit. If I could just have a look. Oh, I think it's dipping that way. We'll go, when you're all doing it, we'll go to places where the dip's more definite and it's almost horizontal dip. But I will be worth just getting a dip. So now what you do is, you get the I'll hold it up so you can all see. There's a red arrow there. Now that, as you might imagine, that points to north when it's horizontal. This is being a compass, you understand. I expect you've got the idea of the way a compass works. And so, what you do is you turn the outer dial there, it has north written on it, so you turn it to point in the direction of north. And then you have to decide which way the rock is dipping. Now I'm just for the sake of argument, because